Hello, we're just going to wait a few minutes for more folks to join. Okay, we'll get started. This is the AVT Core Virtual Interim. We'll have 2 hours today, and info on the notes and the meeting links and other information is on this slide, and we'll provide more of the same in a bit. So this is Meet Echo. So you enter the queue using the hand icon, and you leave with a similar icon. And please enable your audio if we call on you, because otherwise we won't hear you. And you also have to unmute and then mute yourself when you stop speaking. And you can enable or disable video. That's your choice. And use of a headset or echo canceling speakerphone is highly recommended. All right. So this is an IETF meeting, and so the note well applies. There are a number of IETF policies that are in effect. And when you participate in the IETF, you agree to follow those processes and policies. A number of them are listed here in the BCPs, definitive info, and so forth. So please make yourself aware of that. And then, in addition, the IETF is intended for professional collaboration networking, and there are standards of conduct. We have an anti-harassment policy and procedures for that, and hopefully none of those things will come up here, but if they do, you can talk to the ombudsman. But we strive to create and maintain an environment in which people are treated with decency, dignity, and respect. Hold on, I'm getting info that there may be more than one MEDOCO meeting going, which maybe is a little bit weird. Yeah, a bunch of people are in another Meet Echo session. Let's see if we can fix this. Hi, Peter. You were in another Meet Echo session?
Yeah, when I looked at the calendar invite, the link was to a different session, and then somebody pointed out to me that looking at the sorry.
So FYI, I'm in both of these at the moment, and there are like 8 people in the other one, and I guess 15 people in this one.
Wow. So why don't we, is there a way for you to communicate to the other one, the coordinates of this one, so they can all come here?
Yeah, I can go tell them to come here.
Yeah, okay. I was wondering what was going on. Thank you. Hi, Jonathan.
Yeah, you really need to be consistent about which link you put into the calendar entry.
Yeah. Well, yeah, it's really odd to have 2 of them. Wow.
Well, the other one was the one in the calendar entry. I suppose this one on an agenda.
Yeah.
Hello. And it looks like they shared the chat, which I guess because it's the Zulip.
Oh, okay. That's okay. Looks like people are coming over to this one. Okay.
Bernard, just to catch up a little bit, I in the other version of Meet Echo, I am volunteered to help take notes, except for the discussion of rock, and
Oh, okay.
I had invited other people to watch that carefully because it is never a bad idea for people to watch me when I take notes.
Okay. Well, thank you, Spencer. I'm very glad that we have now merged the parallel universes. Have everyone in the same meeting.
At least as far as the one we know about.
Exactly.
Perfect.
So, Jonathan, I guess you had been in the other meeting going through the slides.
Sure. Yeah.
How far did you get?
No, I didn't start the slides. I was waiting for you.
Okay. All right. I was waiting for you. All right.
Oh well,
So I think we're all together now.
I think so. Yes, or at least we don't know of any other meetings.
Okay. All right.
Okay.
So we've gone through the tips. Well, hopefully everybody knows, and the note well, and the note really well. So how about Jonathan? Why don't you take over the chair slides, and I will shut up here.
Okay. Do you want to keep driving the slides, and I'll just talk?
Sure.
Okay,
Sure.
sounds good. All right. So yeah, so about this meeting, as mentioned, Spencer has volunteered to take notes, but he is also presenting. So please, somebody else volunteer to write down any important action items while he is talking. You can use the note-taking tool, which is in your toolbar in the upper right. It looks like the square with the pencil over it.
And as always, you can also correct anything that Spencer gets wrong.
Yeah, so if you think that he, particularly if you think that he did not correctly capture what you said, and you want that what you said, you think what you said is important, presumably you do, because otherwise why would you have said it? Please make sure it is captured correctly in the notes. All right, next slide. All right, draft status. Published a bunch of drafts. I think these were not that recently. Skip, let's see, BP9 is still in misref on indirectly on frame marking. Skip has 3 discuss positions and more discussion today. Frame marking is still waiting for for an AD. Frame marking is still waiting for a revised ID, but Mo isn't here, so I can't nag him. And EVC is an IETF last call. Next. We adopted 3 drafts. We have a call for adoption on 1 more, which we're discussing today. And I think there's 1 more I was supposed to issue a call for adoption on, but I forgot. So I apologize for that. But we will be discussing it today anyway. Next. Okay, there was an issue that got pointed out about the IETF registry for the RTV payload types. There is an IATA MIME types, which is complete. I think everything, all our payload types are there. The question is, do we care about this? Which is to say, do we, I mean, I feel like it is probably bad to have an incomplete registry. The question is, do we want to fix the registry or do we want to tell IATA to abandon this registry? So if anybody has any opinions on that, please come to the mic.
Yeah, Harold, you have an opinion. It came up on the WebRTC mailing list in W3C.
Yeah, the bad thing about these 2 registries is that types that are registered in one are not necessarily usable in another. And the RTP payload types registry is the ones that are usable in RTP, while the other one is usable for basically for files, and that's kind of silly.
Yeah, I mean, I think that's true. I mean, do we think that having that registry, I mean, do people ever go, hey, what payloads can I use in RTP? Let me check this registry. Because it seems, yeah. I mean, maybe they do, because that's why somebody was mentioning on.
Yeah, well, what could happen in theory, at least, is that they look into the one of the registries and don't find the RFC they're looking for and conclude that it's not registered. It would actually be better to add just one that with a flag that says usable for RTP or usable for files.
Yeah.
But that would involve changing registration procedures. Damn it.
Yeah, dealing with the media types people might be.
Well,
Stefan?
dealing with the Media Man working group. So,
That's true. That's you.
yeah. Guilty as charged.
Yeah.
Stefan?
Stefan?
Yeah, trying to unmute here. I'm usually against boiling the ocean in any which way. Harald, how much work is it to fix this? So my understanding is what you propose is to fix that for good, but that would be going forward, or that would also affect all the old stuff? And second question would be, how much effort and work is it to just do this other registration? That would be one RFC with like 2 pages of content or something?
So
I mean, I think the main issue is, I mean, we know some of the, prominent RGB payload types is missing. The question is, somebody would have to go through and find all of the, see if there's any obscure payload types that's missing. And we need somebody to volunteer to do that.
No, I disagree. Why? Why not being pragmatic for a change and just fix the problem that actually may have a real world impact, rather than going back to Sun Microsystems, whatever uncompressed video stuff from 30 years ago.
Yeah, I mean, the problem is people are missing stuff that is widely deployed. Like
Yeah,
the
that's true.
ones, yeah. So I presume also EVC is probably going to end up missing as well.
Yeah, I mean, I think the other thing we need to do is figure out what we need to put into the recommended IANA registration boilerplate for an RTP payload to make sure that IANA puts it in this.
This is Spencer. Can I just ask, make sure that I'm getting this clearly in the notes and people can type also. But the problem is basically that there are widely deployed RTP payload formats that are not in the MIME type registry. Is that
No, they are in the MIME type registry. There's a second registry called the link is there,
types.
RTP payload types, which they are not in.
Right.
Okay.
Okay, but those are widely deployed RTP payloads.
Yes, exactly.
Oh, that's even more interesting. Thank you.
Mm-hmm.
I got that backwards.
Yeah, so we have two different payload type registries that are, one is specifically for RTP and the other one is, generic media types. And some things are only in the generic media types one, presumably because our IANA instructions aren't clear enough. I would explicitly say to add it to this table. Stefan?
As you mentioned, EVC. I don't know how many have paid attention to that, but there was a last call comment from Murray, I think, about that the registration that is in the EVC payload format is limited in scope only to the use of RTP. And we had the same language in the VVC payload format, and that was to avoid a discussion whether this is a binary format or not a binary format, or I don't know. I don't know about that stuff, nor do I care much about it. But I wonder whether, if we are boiling the ocean there rather than finding a really quick and dirty pragmatic solution for stuff that's relevant to this universe, I wonder how much rat holing can happen in this area. So
I mean, I think we certainly don't want to go finding file formats for everything that has an RTP payload format. That would be a very
here's my offer. If someone who knows about media types is willing to help me drafting a 2-pager or a 5-pager or whatever number of pages it takes, that solves a pragmatic problems for codecs I care about, and throw in another 3 or so which I don't care about, then I'm willing to do the work.
Okay.
Anything, and I think it's also fixing a historic problem may be different from finding a solution going forward. So there's no reason not to do both, right?
Yeah, we should probably talk to IANA, like what would be the best wording in the documents to say, hey, we need this to be in the
both of these, right?
So this sorting out someone has to do who knows the people there and who knows how this works. I'm willing to do the legwork, but not more than that. So
okay.
Well,
thank you. So I think that, thank you, Stefan, for that offer. I think we probably should accept this. And once you do the inquiry, you can come back and tell us what.
I think you want somebody else to do the inquiry. Yeah.
Oh, okay.
Yeah.
Well, then we can do it. John.
Yeah, I think we probably as chairs is their best bet. Yeah. All right.
Okay.
Yeah. Yes.
So we will. Yeah. For the notes, chairs will follow up with IANA and try to figure out what's what. And we'll come back.
I am typing that as you speak. Thank you.
Thank you.
Okay, thank you.
Next
All right.
slide. Okay. All right. Yes, I was. These are two things that I think that I was supposed to do last time and forgot, and I apologize. And so, please put those in the notes for action items for me this time.
All right. So these two things,
Hmm.
I think we'll discuss the S-frame one today as well.
Yes.
All right. So these are two action items we'll put on our action item list.
Yep.
All right. I think. Thank you.
Do you want to just cut and paste those into the yeah, perfect. Thank you.
Anything
Yeah,
else,
and
Stefan?
just to make double sure that you're not going back and ask for another adoption call, right? The V3C thing, that's a clerical error on your side and not an.
No, that's a working group last call,
No.
not a call for adoption.
I got it, but that will be issued now.
Yeah, that would be the last call will be
Okay,
issued for V3C.
Wonderful, thank you.
Yep. Okay, here's the agenda.
All right. Okay, here's the agenda. Anybody has any comments on it? And otherwise, we're already a little behind schedule, so I apologize for that. We'll try to keep things relatively on time. But yeah, JPEG 2000. Pierre Anthony? Not sure how you.
Yep.
That's your full name.
Can you hear me? Hello?
Yes, sorry. I had just muted myself, and so I couldn't respond. But okay, yes,
Okay.
I hear.
Great. Yes, hi, my name is Pierre-Anthony Lemieux, and thank you very much for having me this morning. And I just want to quickly go over a proposed RTP payload format for the IETF standards track. And this is to tackle an old friend, JPEG 2000. And there's an internet draft available at for those that are interested in following along. I'm not going to go into too much detail. The draft is pretty complete. So maybe next slide. All right, and on the call is also, and by the way, these are our photos from probably 10 years ago. So also on the call is David Tomman, who was one of the original authors of JPEG 2000 and who's also one of the co-authors of the proposed payload format. So this is intended to be interactive, so feel free to interrupt, ask questions. Next slide. All right, so JPEG 2000, for those that are not familiar with the image codec, it's been an ITU and ISO standard and IC standard since 2001. It's really the Swiss Army knife of image codecs, supports lossy, lossless, resolution and quality scalability, high dynamic range, multi-channel, subsampling. It's royalty-free and it's widely used in high-performance applications, both image and video, and so are some of the examples on the top right. And it's a standard in medical, geospatial, satellite, archival, cinema. It's the standard for cinema distribution worldwide, studio post-production. And it's been essentially continuously maintained and improved since 2001. And David and I, and also Mike Smith, who's on the call, have been particularly active in the past couple of years, making sure to keep JPEG 2000 up to date and be responsive to feedback from users. And so one of the feedback from JPEG 2000 users that's been consistent over the years had been that its entropy coder was particularly slow. It was an arithmetic coder. And so in 2016 or 2017, we started an effort to provide an alternative to the arithmetic coder. And so that's the next slide. So proposing an alternative to the original arithmetic coder, it's called HT block coder. It's a much higher throughput block coder. I mean, I could talk for hours about this, but basically it provides an increase in throughput by basically an order of magnitude. Of course, it depends on the bit rate, but kind of overall number is an order of magnitude increase in throughput for JPEG 2000 at the cost of about 5% increased file size. So 5% decrease in coding efficiency. And that's really, that was a new part of JPEG 2000 that was published in 2019. And this particularly new part really opens the door to inexpensive and high quality, low latency streaming. And so if you go to the next slide. And so that really was one of the motivating factors for starting work on proposing this new RTP payload for JPEG 2000, which is intended for streaming of video signals encoded as a sequence of JPEG 2000 code streams. So it's not every frame, as we'll see, is one code stream, and it's just a sequence of code streams. There's existing RTP payload for JPEG 2000. And again, so the idea here is to improve on this existing payload, and as we'll see, support and leverage some of the advances in JPEG 2000, like this part 15. And we'll go over some of those in the next couple of slides. So support sub-code stream latency, also allow resolution, equality, scalability at the RTP packet level, and so forth. And it's really designed to meet the needs of today's applications, like, for instance, SMPTE-ST2110, which is a standard for video streaming, well, for audio visual streaming in professional broadcast applications. All right, so next slide. So pretty straightforward payload structure. There are two types of RTP packets. One is a main RTP packet that contains the code stream header information. So, and then a bunch of body RTP packets that contain the rest of the JPEG 2000 code stream. Both types of RTP packets have a 64-bit payload header. And so next slide. So nothing exceptional there, I think. Kind of high-level basic parameters. The media type that's being proposed is video/JPEG 2000 SCL. That's SCL is for sub-code stream latency. Kind of typical use of the RTP header fields. The marker just signals the last RTP packets of a code stream. The timestamp field is a presentation time of the video frame or field to which the code stream corresponds. And the sequence number is extended by an extended sequence number, as in RFC 4175, and that's to accommodate very high throughput, very high, well, I should say very high bit rates that are typical in some of those high performance applications. So nothing exceptional here, I think. Next one. All right, so what is sub-code stream latency? I thought that maybe I should spend a slide on this because maybe not everybody's familiar with this, and that's the ability to start transmitting parts of the encoded image before the encoding of the full image is complete. And that makes very, very low latencies possible, so just as an example here, that's a kind of a practical number. So 32 video lines at 1080 lines video at 24 FPS, that's a latency of 1.2 milliseconds. And that's very useful, for instance, for applications. So, okay, next slide. And enabling this kind of sub-code stream latency is actually non-trivial because in order to recover from packet loss, you have to identify resync points within the code stream. And it turns out that JPEG 2000 has forever included the ability to provide those resync points, but unfortunately, that's provided as metadata, which is in those PLM and PLT markers that are actually stored in the header of the code stream. So unfortunately, with kind of standard JPEG 2000, it is not possible to write those markers until the entire code stream is created, which kind of defeats the purpose of enabling sub-code stream latency. So this RTP payload format introduces two fields in the payload header, which identify resync points in each RTP packets. And these are the POS and PID header fields. All right, next slide. Also, resolution and quality scalability. For those of you that are familiar with JPEG 2000, it's possible to packetize, to organize JPEG 2000 code streams so that they're organized in order of quality or resolution levels. So for instance, in this particular illustration here, all the low spatial frequencies are stored at the start of the code stream and all the high spatial frequencies at the end. So we have two additional fields in in each payload header that identify which quality and resolution levels are present within each RTP packets. And so the idea here is the receiver or network agent can just select quality resolution levels at the RTP packet level without having to parse the code stream. So you can simply, for instance, the network agent can easily just generate a half resolution version of an image just by getting rid of RTP packets, dropping RTP packets. Okay, next slide. Another feature of this proposed RTP payload format is high precision clock recovery. So the RTP timestamp is pretty low resolution compared to the RTP packet rate, especially at high bit rates. And so there's in the payload format, there's an additional header field that indicates the transmission time of each RTP packet in the same time base as the RTP timestamp. And that allows for increased clock recovery speed and resolution of the receiver. And that's an optional feature that's enabled using a bit in the header field. So that's another something new feature of this payload format. Next step. Another feature is code block caching. So JPEG 2000 can be used or has been used to transmit video content that consists of mostly static content. So for instance, just screen content. And of course, the idea there is you'd like to not have to retransmit continuously the static parts of the image. And so the payload formats introduces a very simple code block caching, which allows the sender to only occasionally transmit code blocks. And I'll go over what code blocks are, but occasionally transmit parts of the image that are static. And on the other side, the receiver maintains a code block cache and that it uses when it receives an empty code block from the sender. And just again, for background, in JPEG 2000, a code block is a collection of coded samples that belong to a rectangular, spatial region within one resolution level of one component. So basically, this allows the sender to only occasionally send code block, parts of the image that are static, and the receiver maintains a very simple cache where it fetches from that cache when it receives, an empty code block from the sender. That's okay. So next up. And I didn't go over everything. So for instance, it compared to especially the existing RFC for JPEG 2000 streaming, and also this payload format supports much finer and much more detailed color space parametrization and signaling and so forth. And anyway, so this is like this to be considered as a standard track RFC, and there's an ID that's been posted, and it's been revised already once based on feedback we received, and we really welcome your feedback and look forward to working with the working group. Thanks.
Stefan?
Is this active now? Yeah. So I read this draft. I find there are a lot of good points here, and I support the adoption. So I want to make 3 points. So first, thank you for using the ITU references and not the ISO references. So we will have no trouble in the normative referencing citation part that we recently had on the ISO side with us. ITU recommendations are free for download, so no issue there. Second, I find this idea of sending the packet send time in a payload head, I find that intriguing. I don't know, has anyone seen that before? It's smart. You know, buffer management can do really, really, really good things. And then one point of criticizing is the way how you guys describe the syntax is like an ASCII-fied version of a syntax diagram as used in JPEG. That's not what we use here. And that's not what the old JPEG 2000 payload format used either. I don't know whether we should, whether consistency with the traditional way of specifying syntax here is desirable, but my guess is it's probably nice, because that's the way how syntax is described in packet protocols in the IETF is basically the same everywhere, and you guys are not following that. So I would suggest to edit that part of the draft. That's editorial work. Yeah, it's not substance. Thank you very much.
Vince, could somebody get Stefan's last point in the minutes? I got everything but the last one. Thank you.
Okay, so Jonathan Lennox, somewhat as a chair and somewhat as an individual. I mean, as a chair, I just want to say I think there's no problem with us doing a second payload type for the same media type. We've done that, I think, at least twice before. I think we did it for MP3 and we did it for H.263, so that's fine. And the normal negotiation procedures between them should work fine, and so there's no issues there. So I think that's fine. Just speaking as an individual, I'm afraid I haven't read your draft yet, but I'll just looking at what you said here. One is that the on the sending timestamp, there is an RTP header extension for that. I think it's one of the first ones to find. And I mean, I would ask, would that work for you? Because I think there's like, some feedback defined in relation to it and whatnot. If it wouldn't, and if there's some technical reason that wouldn't work, that's fine. But I think you should at least take a look at that. I could probably find the RFC number for that if
Yeah, that would be great.
Absolute send time or something else, Jonathan?
I think. Let me see.
One of
I'll look.
Okay, yeah, one of the design goals, so I had not seen that, so that would be great to have that as a reference. One of the design goals was to keep the header to 64-bit so that it's easier on hardware, FPGA.
Yeah, I mean, so this would be the RTP. This would be the RTP header extensions rather than the payload header. So it's actually yeah, I think. Yeah, transmission time offsets. That's RFC 5450.
5450. All right, thank you.
Yeah, and then the other question I would have is just on that. I guess JPEG 2000 mostly doesn't have interframe dependencies like things that are like more video codecs do, but I guess your block cache does. And I guess my question is there a way for a receiver to tell that it's lost a packet that contains something that should have been cached? Because obviously things would go badly if it did. You'd end up referencing either having a cache miss, which I guess you could tell, but you wouldn't know what you missed, or you'd actually potentially load the wrong thing from the cache. And there's various techniques we've developed, so that might obviously make your header bigger, which you don't want. So have you looked at that, and can you tell if you've missed a packet with the cache, the C flag set?
Well, it's possible to tell if you've missed a packet in general.
Sure, yeah.
So, but if you join a stream in the middle, it may take some time for the receiver to build its cache, essentially.
Yeah, no, I think, I mean, yeah, I guess, do you assume that you have some reliability mechanism and that basically, would expect that normally all packets would eventually get there?
Well, I don't think that can always, and we can
Yeah,
never say that
I'm
about
just sort of
RTP.
thinking, no, I mean, I just think there's ways I mean, we don't have to discuss this online, but I'll look at your draft.
Yeah, I'd love to discuss it in more detail. And and of course, the sender, for instance, knowing that the network quality, the network conditions are bad, might choose to not send empty code blocks less often, right? So it's really this architecture. It gives control to the sender to decide, how often it does not send a code block.
That's fair. Stefan?
Regarding this discussion, this sounds a little bit familiar from things like the Opus payload and places like that, where there were also like code books formed, and they and the error resilience of that was debatable. Let's put it that way. I don't think they have. I don't think they were talked into specifically addressing that. And I don't think we have a history of specifically addressing, incorrect reference information that may be incorrect because the data stream is not good. That said, what people do outside of RTP payload formats, but could be also implemented inside of the RTP payload formats, is to have something like have a header field. This is the checksum calculated over your current cache. And then the decoder sees that. And if the decoder sees that and it doesn't match its own checksum calculation, then at least it knows that there's something wrong and can do whatever is sensible to do. And in that point, then comes the question whether there's something like an adaptive form of a full inter request ought to be transmitted in a back channel, and that for that this 4585 type of stuff could be in adapted form useful. So I think a little bit of error control support in the payload format is probably not the worst possible thing for this guy. But again, it's already a fairly complex document, so let's keep that in mind too. It's IT style and fairly complex, so we would add complexity there. Thank you.
This is David Torben here. I wonder if I could just briefly address that. The code block caching, I think we might be making a bit too much out of this, or more out of it than is really intended. This is really building upon the fact that JPEG 2000 is both error resilient and also extremely robust to just missing pieces. So this mechanism actually really just encourages the missing of pieces and provides a default strategy, an alternative default strategy for handling missed pieces. It could almost be considered like an error resilient strategy. So we don't really need to worry about the resilience of the method, because essentially the method is intended to work with a codec which can decode the content perfectly fine, even if virtually any arbitrary piece is missing apart from the main header. So it's kind of intended to operate in that environment.
Yeah, I mean that makes perfect sense to me. I mean, my more of a concern is not, dependent, and I don't know exactly how your cache strategy works. What would happen if you not that you cache entry is missing, but the cache entry is wrong because something later updated it? And if every cache entry has a unique ID, that's fine. But I mean, I'm worried, like, if you're showing static image and then flip the screen and you miss the flip, then you might, fill the, think you can reference the cache from the previous image. That'd be bad.
That is a good point. Yes, that is a good point. Of course, the thing will eventually be replenished, but that is a good point.
Yeah. Stefan?
This is my final one on this draft. Given that there are these great ideas in here, you guys are aware of the patent policy of the IETF and your disclosure obligations, which is triggered right now, obviously, right? I hope you are. Thank you.
From the point of view of the notes, what are the next steps here? Or
I just want to address the previous comment, and thank you, Stefan. Yeah, absolutely. very much aware of those. Thanks.
So I think the next step is you'd be looking for working group adoption, I assume.
That's what we would request. Yes, please.
Okay.
Item is on the chairs to issue a call for adoption.
Yep. Okay. I'm sure that's in the notes, Spencer.
I do have one question, if there's just a few seconds. In terms of collecting issues and feedback, of course, the mailing list, is there an issue tracker, or should I just open an issue tracker on GitHub, or how?
I mean, we have a GitHub for the working group, so I think you can work with the chair, so you can we can import you into that GitHub repo, and you can do stuff there if you'd like.
Excellent, thank you.
All right, thank you.
Well, thank you very much, everybody, and looking very much to your feedback and continued discussion, and to the call for adoption. Thank you again.
Okay. So next item is an HCBC profile for WebRTC. So we have with us on this call myself, as well as Philip Hunke, and some of the developers of the Chromium HCBC support. John Lin is here. So we're going to be going over some of the feedback we got during the call for adoption, and hopefully solving some of the issues. So here's, we have a GitHub, and a bunch of issues got filed there, and I'm going to go over them individually, and hopefully we'll come to agreement on what to do next. So issue 2 is about the out-of-band SPROP, VPS, SPS, and PPS. In RFC 7742, which was the original WebRTC video RFC, it basically says that WebRTC implementations must signal this information in band and must not include in the SDP they generate. So that's kind of the past history. And this draft does something similar, basically saying also that this is, it must be signaled in band and not not in the SDP. And so the question is, do we have consensus to keep the approach of 7742? Any opinions? Let me put it this way. Are there any opinions that the take of the draft so far is wrong and should be changed? Okay. Yeah, Stefan and Srinivas. Stefan?
Yeah, this unmute takes a while here. I'm willing to accept this on a pragmatic basis. I'm the one who proposed originally out-of-band parameter sets back in 2002, but it hasn't taken off in this environment. So let's just follow practical implementation practice rather than options that are available in according to the words of the standard. Thank you.
Srinivas?
Hi.
You need to unmute.
Yeah, sure. Sorry, I was actually waiting. No, sorry. Yeah, thank you. So I just wanted to check. Not providing them out of band or in the SDP will probably delay the joining of the session for WebRTC client. So how, I mean, in this case, we probably have to send the SPS, PPS information along with every ID or frame or an iframe. So why we consider this approach of not including them in the SDP? Any specific reasons for not allowing this kind of information in the SDP? Because this must not is a strict implementation that it should not support it. It shall not support it. Sorry.
If I can speak to that, as an individual, but with some implementation experience, I think the reason why we did this for H.264 is because in practice, video codec, interactive conversational video codecs change resolution a lot, which is going to need a fresh SPS PPS, and whereas STP doesn't tend to update that often, and also you can't necessarily guarantee that an encoder is going to pick different SPS PPS IDs, and trying to decode with the wrong SPS PPS causes chaos. So you're better off. So yes, this does mean you have to send SPS PPS with every IDR, which is what people normally do. This is what it says here. Yeah, which is what you normally do for H.264. But that's better than being in a situation where you might end up trying to decode with the wrong SPS and PPS, which would be cause very strange things to happen. I think because you can't necessarily even parse your video frames if you've got the wrong SPS and PPS.
Okay.
Yeah. So we did have a PR created to address issue 2, which is to clarify this, because as Jonathan mentioned, some of the encoders didn't update the ID, and there was some issues in matching the in-band sets to the IDR. So PR10 adds the following text, basically, to say the IDR must be preceded by the relevant parameter sets with the same RTP timestamp. Any problems with this, PR? Okay. All right. Issue 3 is about TX mode. The current draft didn't cover that at all, and then people said, "Oh, okay. What should we do here?" And so I created a PR9 to try to update this. Basically, the guidance is to not include the parameter within STP, should not. And if it's present, then as the RFC 7798 says, a value of SRST must be inferred. So that's PR9. There was a remaining question, which is what happens if the WebRTC browser receives an offer with another mode like MRST or MRMT? Typically that would, because of the guidance here, would come from a gateway, not another browser. And should the set remote description just fail to apply it? Because 7798 section 4.3 says that receivers must support all of the TX modes. So I don't know, John Lynn or others have an opinion on this. John Lynn, do you want to speak to what you'd like to have happen? You need to unmute.
I think I'm unmuted.
Yes. Are you speaking? We could hear you. John, you seem to be muted now.
Yeah, I mean, I would prefer the set remote description to fail if you get an offer with the text mode, not set to SRST. That's my preference. But I'm not sure why RFC 7798 states that receivers must support SRST and MRST and MRMT. But implementation-wise, this makes things easier. I'm not sure why previously this becomes a requirement for supporting all TX modes.
Jonathan?
Yeah, so I think
We wrote it that way because we didn't know what modes people were going to use. I mean, I believe in practice, I don't know of very many H.265 payload type implementations yet anyway, but I certainly don't think that anybody's implemented MRST and MRNT. I know that, like, for instance, for VVC and EVC, we decided they're not worth implementing, and so we only defined SRST for VVC and later codecs. So I think that I would think that I very much doubt that even from a gateway you would get anything that isn't a SRST, because I don't think anybody decided to go that way. So my inclination would be to say this is that it's fine to fail. I mean, if you feel like implementing it, sure, knock yourself out, but I don't think we should require the browser to implement it in the spec.
Okay. May we put that into the notes as recommendation unless there's an objection?
Sounds good to me.
Okay.
And just a Spencer recommendation from who?
No,
Well,
go ahead. Sorry.
Yeah, the just sense of the room is that it's okay for set remote description to fail.
Yeah. Thank you. I was just lacking a lacking a noun. Thank you.
Mm-hmm.
Okay, for either MRST or MRNT. Okay. All right. Next issue is issue 4, and so I believe John Lynn questioned the usefulness of max CPB and max DPB. And just to clarify, these are additional constraints on top of the level ID. So they're put in if the receiver can't handle what would be implied by the level ID. And that includes, in the next issue, we'll talk about max FPS and max BR. But so the proposal here in PR 8 is to remove these as parameters that we expect WebRTC implementations to support. So basically what we're saying is we're assuming that implementations don't need these additional constraints, and that the level ID is sufficient. Are there any objections to removing max CPB and max DPB? Jonathan?
Yeah, I think this mostly, I mean, I will defer to the implementers here if that's what, people who are actually talking to the actual codecs, if the level IDs are sufficient to describe what the hardware codecs are doing, then yeah, let's do that. If there's like ever any case where like a hardware codec is, well, I can't quite, I mean, these are actually above the level ID, not additional constraints below the level ID. But it's what I meant to say, well, I can't quite do, I can do this level, but I could do more CPBs or DPBs than the level ID 60 specifies. But I suspect that's not what.
Okay.
Yeah, I suspect that's not what hardware implementers are doing, and at least there's no API to specify that. So in which case, you don't probably need these.
Okay. So the next issue is similar but relating to max FPS and max BR. And we had some discussion in the issue. People were saying, well, in VP8, we did want max FR and max FS. And that was an issue. It was required in 7742 that be supported. It wasn't supported, and then there was an issue and 34 stars, which meant people were upset that it wasn't in there. But HEVC is different than VP8 because you have the profile tier and level negotiation, and VP8 didn't have that. So again, as Jonathan said, it's an additional parameter in addition to the level. So it isn't quite the same thing. So the question is whether we need the max FPS and max BR. or whether the level ID is sufficient. And PR15 removes max FPS and max BR as parameters. Jonathan?
Sorry, that was a lingering hand. I don't know. I have an
Okay.
opinion about that.
That's Jonlin, do you have an opinion here? I guess you, I think you were okay with removing all this stuff, right?
Yeah, I think I'm okay to remove this because I think it's kind of overlapping with the level negotiation, right?
Mm-hmm. Okay, are there any objections to this PR15, which removes max FPS and max BR? Okay. All right, so the next one is the PACI packets. These are defined in section 444 of 7798 in the payload type 50. And then in 4442, we have the temporal scalability control information, TSCI. So the issue here is that in WebRC implementations, this TSCI info typically ends up elsewhere as well, such as in RTP header extensions. I believe the overlap is, there's a bunch of them that overlap, including the frame marking RTP extension, but also dependency descriptor or generic frame descriptor have this kind of S&E kind of bit information. So the question is, if it's negotiated in these RTP header extensions, what do implementations do if they get the TSCI also in the PACI extensions? So you could essentially get this in two places. And so in PR16, basically there's a proposal to say, hey, if you negotiate these header extensions, the TSCI in the header extension takes precedence. And then the implementation must ignore the TSCI in the PACI.
I mean, that's assuming you understand them. I'm worried about some of the SFU cases, particular like if some receivers understand the header extension and some don't. I would be inclined to say must be consistent, and other than that,
when you say must be consistent, you mean
basically you can't say you have to I don't know, but basically you have to tell the truth. I mean, I don't know. You can't say don't be wrong, but basically put them both places, and it's because I mean, I'm concerned like about a a SFU that needs to strip them for some receivers and things like that.
Well, but then the header negotiation, header extensions would be with the SFU, right? So you're saying
True,
basically
yeah.
it negotiates them, but then it doesn't do it right or something.
Or it negotiates them, but then wants to forward the packets on to other receivers, and then I mean, I'm worried about the case where the sender would just not bother to put them in into the payload format if it's negotiated the headers, which actually happens with VP8 on Chrome. So yeah, I mean, I feel like this is an issue. I'm not sure specifying this. I feel like this is an issue we already have with other payload formats. I'm not sure that specifying it specifically here is that helpful when we already have the problem for existing payload formats. But that's an individual opinion. So if other people disagree with me, I'm willing to be in the rough.
Jianlin, I know you had an opinion on this.
So because we don't see this for ABC, right? This TSA CI information, it's kind of inconsistent. Because as Robert, you mentioned, we have a duplication here. My take is that if you already negotiate the DD extension, I agree that you should honor DD first. Otherwise, if DD is not negotiated, then we can honor the TSCI information. So there must be some preference here.
Then what do you do about it, right?
Yeah. I mean, if DD is there, we ignore TSCI. But if DD is not there, we will honor TSCI.
Yeah, I think it's reasonable, Jonathan, to say they should be consistent. I think you probably would be somebody would be screwed up if it wasn't. But the question is how the receiver, processes the whole mess.
I mean, does it? I mean, and does it need to be specified if they must be consistent?
Hmm.
And I think more interestingly is, should you say, should you bother sending PACI if you've negotiated DD, or should you just omit it?
Right. That's the other question. Yeah. Some ways it would be easier if you didn't, right?
Mm-hmm.
John Lynn,
save bits somewhere.
by default, right? Are you planning to send it even if you have the RTP header extension? No, you're not planning to send it. Yeah. So maybe for the notes, this should say something like if it's negotiated, senders probably shouldn't send it.
Yeah, that's fine for me.
I believe that's what Chrome's already doing for other payload types.
What I just heard was, if this is negotiated, senders shouldn't send it.
Yeah.
What was it?
Sorry,
the TSCI.
Okay, thank you. If it is negotiated, cool.
Basically, if it's negotiated in a header extension, don't send it in the payload.
Oh, okay. Oh, thank you. That was the part I was not able to lace together.
Yeah. Okay. Thank you. I will modify the PR and we'll talk about it in the GitHub. All right. So last issue relates to RPSI, and I think more generally to alternative reference frames and references in general. So basically, the question was, should this HEVC implementation support RPSI? And it also got into how the references are handled, et cetera. But I think looking over the RFCs, the sections are fairly clear. So RFC 7798 section 8.3 defines how to support RPSI and HEVC. So that's there and it's clear. And then there's a use of RTP in WebRTC document RFC 8834, which basically says that receivers should generate the RPSI and then the receiver should act on it. So that's pretty clear guidance. And then there's also some clarifications in RFC 8082, section 6.3, basically how to deal with the RPSI in the context of layered codecs. So I think the RFC guidance is pretty clear here, but there are some practical issues that are in WebRTC implementations that are worth talking about. In particular, LibWebRTC hasn't supported RPSI since 2017. It did initially support it for VP8 and VP9, but it was problematic and it got removed. The H.264 implementation does not support alternative reference frames, although some people would like it to do that, it doesn't. And then the AV1 payload spec doesn't mention RPSI, so it's not supported for that either. Jonathan?
I would suspect, my suspicion is that given that this is entirely targeted towards hardware implementations, and I suspect that hardware implementations generally don't support any kind of reference picture selection, or at least most of them don't. It seems, I'm not sure that this is useful, would actually be implementable, even if.
Yeah. Harold?
Interestingly enough, the question of reference frames came up in at the WTC last week.
Right.
Week before last, and the claim there was that, according to my colleague who had talked to hardware manufacturers, reference frames were perfectly reasonable to designate on the hardware, but only 2 of 3 operating systems would allow you to direct the hardware to do the right thing through the drivers.
Right.
So yes, it was dealing with reference frames sounded like it was quite feasible if the push for supporting it was strong enough.
Yeah, and at TPAC there was a new encoder API discussed that would actually make this possible to do in WebRTC. So there was that code limitation which potentially could be removed. Stefan?
I hate MeetEcho. So RPSI is from all the error resilience tools that are using media coding features. RPSI is really the most efficient, right? It's really great stuff. And with respect to HEVC, while I haven't seen hardware or drivers or stuff that would support that, I would just from a theoretical analysis of the codec itself, it shouldn't be particularly hard. The reason is that HEVC's need for metadata associated with each reconstructed frame, that's absolutely minimal. That's different with the Neo codecs and including AV1 there, but for HEVC it's absolutely doable. Yeah. So on this one, I'm tempted to recommend to at least leave the door open, because it solves a real problem, and I wouldn't rule it out that reasonably smart people would implement that in the foreseeable future. And if you provide now guidance not to do it, that's it would probably just trip the implementer community away from something that's actually useful and works. So I would be silent about that at this point. Thank you.
Yeah, so Stefan, because the use of RTP in document says it has a recommendation, I don't think this document can override that. It already says should implement on the sender and the receiver. So
yeah, but but you can still. I don't think standard formalities here should count, right? What you. I mean, you could make a must out of it, but I wouldn't go in that direction either, because you can't enforce it.
Right,
I would just be silent on it.
Harold?
Yeah, just another note is that we currently have a CL in progress for libWebRTC that adds RPSI support for H.265. So the fact that libWebRTC
You dropped off for a minute there, Harold.
Yeah, suddenly mute kicked in. So the fact that libWebRTC doesn't support RPSI at the moment doesn't mean that it won't support it
Mhm.
tomorrow, or whenever that CL gets reviewed.
Yeah, so I guess John Lin, you're the author of the CL, right? So I don't know if you want to comment on it.
Yeah, so yeah, I draft that still because a few customers like Meta and Zoom request this to support long-term reference. Actually, hardware supports this and driver supports this on Windows for most vendors. So this is not only HEVC specific, but also AVC supports this. So this will be very useful feature when you have a packet loss or frame loss. And with this long-term reference picture selection, you avoid sending keyframes, right? So this
Right.
is a very important. We would like to have that.
Okay, so how about this proposal? Basically, keep with the existing RFCs, recommend the support for RPSI, maybe quote the other RFCs, and then try to land the CL and make it happen. And if we have other issues, we can come back to the working group. Does that seem like a reasonable resolution of this? Are there any objections? Okay. So I think that's it for the issues. I don't know, Jonathan, if you want to comment on the call for adoption, but that's it for the issue discussion today.
Yeah, I think there were a number of people in favor and nobody against. So I will review the comment, but I think we should adopt. I think the call for adoption is a good one.
Okay, and then
I will
for
send a
the
formal put a action item for me to declare to send a note to the list saying that.
yeah, send a summary of the call for adoption,
Yeah.
Spencer,
Yeah.
in the notes.
Okay.
All right, and then
Could I
yeah.
ask? So I will do that. Could I ask someone else to take over as note taker? I am am
About to
starting
present,
to
right.
get complicated here. Just just as far as me trying to stay focused. Thank you.
Thank you.
I'll keep watching, but I'm not going to be typing. Thank you.
Okay. All right, RTP payload format for skip. Dan or Mike?
Yeah, this is Dan. So next slide, we released version 6 last Tuesday. Some minor updates to it to added a key point section to try to summarize up front in the beginning of the document some of the repeated questions we seem to keep getting from reviewers, to try to bulletize those points right up front to address those concerns. Again, just to go through this quickly, again, the skip can be considered a tunneling protocol. Payload is opaque. That's kind of one of the things we wanted to drive in right up front, that is what is going on. Again, skip is an application protocol that uses RTP as a transport. And again, to emphasize the third bullet, again, we are not like most other RTP payload RFCs in that we don't have a concise or discrete payload format. Rather, we're tunneling other codecs through the skip payload. Again, the reliable transport is done through skip control messages. Again, that's implemented at the application layer, and we have versioning mechanisms within skip to avoid the obfuscation of the protocol. We also added an example of listing skip in preference order when there are multiple codecs listed in the STP. And probably one of the bigger changes that we made after getting approval from the skip working group was to actually provide a link to an older public version of the skip 210 specification. Again, that was repeated over and over again by all the reviewers, that that they weren't getting the document or they didn't request it or whatever when they did the review. Therefore, they couldn't do a review or did an incomplete review. So again, we provided that specification. Again, the basic principles and protocols that are defined in that older version are relevant today. There's not been too many changes regarding that level of specification, so we felt comfortable in providing that public link to everybody at this point.
Yeah. So yeah, I think you're in an interesting position because you've provided the public link now, and now we're starting to get people reading that and asking questions about the skip state machine, and
right.
Act as though I mean, the info's out there, so you can ask the questions and we can answer them, but they're really not relevant to the draft. Like we had a question about video and the state machine and when it gets turned on and the key exchange and so forth.
Yeah. Sorry. You're
so
correct.
Yeah, so it's going to be, it's interesting. You've now made it clear that the information is available. So now they're going to read it. Now somehow we have to get out of this because it is a tunneling protocol, right? Which means, yes, you have all this great information now, but please don't make use of it.
Right.
Yeah,
And that's sort of the trade-off we did with the sense of trying to,
right.
With all these reviewers saying, well, we can't do a review because we don't have access to the document. So in the effort of trying to get this thing moving forward here, we sort of capitulated and say, well, we'll provide the link to the document so you can do a review. But like you said, don't do a deep dive because we can't, the protocol is what it is and we can't change it. So
well, also because it's not relevant, right? I mean,
that's true.
As an example of the latest one was when exactly does the video state transition to secure for video, and the various versions of skip 210 maybe have different answers you mentioned, but it doesn't really matter because you're just going to take the payload and stick it in RTP, and and if you're intermediary, the whole point is you shouldn't be parsing the thing to try to figure that out anyway, right? Because that would break the whole thing. So
yes, if I may comment, you're exactly right. The question coming in about the video mode is you don't want to be harsh, but the truth is it's out of scope for what this draft RFC is trying to do. We're a tunneling protocol. What is in that payload should be opaque to any device other than some skip device. And if you really want to learn skip and make a skip terminal, we can happily turn you on to people who can assist you learn to do that. But this is not the point is,
well, and also that info that you would learn to do that should not be applied in the middle box.
Correct. Nothing should go on in the middle.
Don't do that in the middle box.
That's the whole point.
Yeah. So yeah, I'm gonna read 06 again, and I think it might be frustrating for you because I think you've now answered the availability and open part, but you've now opened another can of worms because the stuff is out there, and now they're all going to read it, and now they're starting to ask all these questions as if the answers mattered.
And correct. And remember, it is an informative reference. It's not normative. It is not necessary for it to be there.
Right.
And I sometimes wonder what would happen if we didn't even list it in there and just submitted this.
Well, because then they'd say you were hiding it.
Well, they seem to say that anyway. But
yeah, but now they can't because it's in the open. So I'm going to read it again, and just if it makes you feel any better, these same questions are coming up in the quick working group because middle boxes, in TCP, we're mucking with things and making all kinds of problems. And so in quick, they have something they call greasing, which is basically they randomly change bits. So, yes, you have all this wonderful info, but we want to make the point that you can't mess with this. So we're going to change it. So if you try, it's going to break. I don't think we want to do something quite as extreme here, but we're just trying to tell people not to use all this wonderful info you've made available. So anyway, I'll go over it and try to see if that point is clear, or else we'll have a whole bunch of new discusses on a different set of points.
True, and you don't want to be rude to people and say, I'm not here to teach you skip, but it is an important
Well, it's even
protocol,
worse.
but
I mean, it's even worse because even if you did teach them, the whole point is don't use that knowledge. Please,
yeah,
please forget everything we just told you.
it's not like we don't have other lives.
Right.
So,
All right.
Yeah, so the final slide just goes over the ballot stuff, the ballot position, where we are
Yeah.
at this point, and what we can do to try to poke and prod to get people to make a decision or cast a vote. I mean, there were 4 people on the list that didn't even cast a ballot. I don't know what's up with that, and try to convince the other some of the other 3 that are in discuss to persuade them in our direction. So
Yeah, I will go over it again to try to. I think what I'll do is I'll also try to look at language in other RFCs that have the same problem, like in Quick. We may need to add a paragraph on protocol ossification to just make it clear why that you're not hiding anything. You're just trying to get that you've got a problem with the middle boxes right now, and that's what you're trying to fix. So giving more knowledge to the middle box isn't going to help you.
correct.
And
The
it
whole
isn't going to
intent of
fix your problem.
the whole intent of the RFC is to try and inform the people who make middleware boxes that this protocol exists, and please don't do anything with it. Just let it pass.
Right. So like the last thing you want to do is have everybody implement a particular version of skip and start looking at the payloads and fooling with it. That's exactly the opposite. That would be worse than where you are now, in fact.
Yes.
Yeah.
Because it would produce problems at various places in the network where it used to work and now doesn't, and now you're
Now
trying
it
to
would
track
break.
down
Right.
somewhere in the middle where it seems to be broken. That would be bad.
Right. Because now you basically got these SBCs that are randomly breaking you, not because you're skip, but because you're a payload type it wasn't set up to handle. So you don't want to transition from that scenario to one where they're understanding skip and breaking you specifically because you're the wrong version of skip.
And we are at a point that would put us in a point in time that we would have to make changes to skip, but couldn't implement until we somehow notify all OEMs of network gear that they need to make a change in place by a certain date so we can roll out our changes.
Right. Yeah, and that was the situation in TCP, which is why in Quick they try to come up with all of this anti-ossification stuff to prevent that same. I mean, in TCP, essentially they've given up at this point.
Okay.
Because that middle box junk is so prevalent that it really can't be removed. So they're in Quick they're taking these anti-ossification, but that would be a little extreme for you to start to get into bit greasing. But yeah.
Yeah, that doesn't help.
Yeah. Okay. So I think for action items, I think just chair review of the whole ossification tunneling language to see if it's clear, and then we'll make another IESG, yet another review request, and see if we change any votes.
all right, thank you.
Can somebody put that in the notes since?
Yeah, I'm typing it in the notes because
okay,
we
thank
really
you.
need a proper news note taker.
So,
especially presenting next
so,
week.
so one thing, it's time to make phone calls. This email stuff, or it's time to actually, talk in person to these ISG people. People, so someone has to go to Prague and they really set up a meeting beforehand and talk to them. Yeah, I think a lot of these comments were still based on lack of education, and no matter how many emails you send explaining every little detail, and no matter how much additional text you're putting in, people don't read. Yeah, even ISG members don't necessarily read. So you have to talk, otherwise you will not get the thing over the hurdle. Yeah, and ISG people are busy in Prague, but set meetings up beforehand. Yeah, I think that's the only way to get this done. Thank you.
I think that's a good point, Stefan. Clearly, the emails do not seem to be working. So anyway, I guess that's a chair work item to discuss how to move this forward as well. Spencer?
Is either of you going over to the IETF this time?
Jonathan, I think you'll be there, right?
I should be. I'm still waiting for formal approval from my.
Okay. Yeah, Spencer?
Just my experience from another working group in Seller. I had asked Murray to chase down and discuss for one of the documents there, and Murray let it slip that there's apparently a Slack instance for the ISGs that he's using to ping other ISG members. So, and that is likely to work much better than email between now and Prague.
Okay, thank you. All right, so we're going to transition over to RTP over quick. We've given it a half hour. We don't quite have that because we're running a bit behind. But
and again, a call, please, somebody take notes. So can somebody volunteer to take notes for this next section?
All right, I'm going to try to make it short. Next slide, please. So yeah, short update on what we've changed since the last meeting. We added a section on considerations for using streams versus using datagrams. That mainly contains some background info about the differences between quick streams and datagrams, but it's purely informational. It does not add any restrictions, so you can still use both in one connection. We explicitly state now that applications are responsible for adaptating rate by deciding what they actually want to send. And previously we had a sentence that said we don't mandate any algorithms, but we made that a bit more explicit and clear now. And then we have PR 120, which moved large parts of the RTCP analysis that we talked about in previous meetings to an appendix. There still is a section and a new issue that I'm going to talk about very briefly later that concerns the same part, but we already moved a large part of the RTCP analysis now. And then the last two pull requests that are listed here, I have some more detailed slides later. And yeah, we published a new version yesterday, 06. Okay, next slide, please. So this is one of the open issues currently, and we have talked about stop sending and reset stream in the past a couple of times. I think this slide doesn't have anything that I haven't talked about in the past meeting. But to quickly recap, if a receiver sends stop sending and the sender must, according to Quick, send a reset stream. We say in our document that the sender still should continue to send media frames of that media stream on new Quick streams, because stop sending should not be interpreted as stop sending me this media stream, but only as please stop sending me this Quick stream. And currently we say that the RTP over Quick sender must continue sending media frames starting from the first one that it hasn't tried to transmit on the Quick stream before. I have one more slide on that. Do you want to wait on that before we discuss, Ben, or do you have a question regarding these points already?
I've been going over the draft with respect to the treatment of RTCP. Mm-hmm. And one of my questions, a bunch of things when you say, for example, send new media frames, I think you also mean both RTP and RTCP, right? Because the stop sending could affect the RTCP as well.
Yes, that's a good point. That's not covered by the text about stop sending currently, I think, but
yeah,
I apply to RTCP too.
I found a bunch of places, and I'll probably file another issue, but relating to the treatment of RTCP, in particular, I think that would be really bad, as if somehow that feedback stopped getting sent for some reason because of getting a stop sending or something like that. Anyway.
Bernard, if I could just make a suggestion. We've got a couple of open issues from you, and 128 is quite an open issue that we have not discussed yet. It is likely that open issue will be sliced and diced into multiple issues.
Right.
And so you are issues are encouraged, but you might want to see where where that where 128 land and its children land, and see if you still need to say something.
Okay, thank you.
And that's actually good advice for anybody, but especially for Bernard, especially on that issue. Thanks.
All right, next slide. So last time there were some questions about what happens if there are media dependencies. And since we say that the sender should continue sending new media frames on new quick streams, but not retransmit the previous ones that received stop sending, there is an issue what happens, for example, if the frame B, the second frame on a stream, depends on the frame A and has to send on a new quick stream. The frame A may not have arrived completely because that's why this receiver sends stop sending. It doesn't want this frame anymore or whatever. And then the sender must continue with frame B, but sending frame B doesn't make that much sense because it may only be decodable when the receiver already received frame A. So we currently, the application is in charge of what's to do with the next frame. There are some options listed here in the bottom of the slide, so that the sender could, for example, decide to drop B because B will not be usable by the receiver. It could create a new independently decodable frame or something like that and continue with that and treat this stop sending as some signal to reset the decoder. Or we could transmit B on a new stream, accepting that it may not be decodable and resulting in some artifacts. But we would like to not add text that allows the sender again to transmit the previous frame A on a new quick stream, because that is an issue that we discussed about in the past, and we needed to add some boundary on where to restart on the new quick stream. So we added this sentence that says start from what you have never sent before. And so we would like to keep this as the boundary, because otherwise we get into a situation that we discussed, I think, in Yokohama, where the sender could treat the stop sending as, okay, I'm going to retransmit the same thing on a new stream, and the receiver will send again stop sending, and it will kind of end up in a loop where the receiver keeps saying, hey, I don't want it, and the sender says you need it to decode the next one. So yeah, we would like to keep the notion that it is now, and maybe add some hints as to what the application can do in this situation. But yeah, we would like to ask if there's any other problem with this solution, or if we need to consider or forgot to consider anything about this. All right, so if there are no comments now, but you have something later, then please add it to the issue. Otherwise, we will just add these hints on what the application can do and then keep this restriction that the sender has to continue with the next media frame. Yeah, Bernard.
Yeah, I would say I would be concerned about interpreting quick layer feedback as RTCP feedback, like treat a stop sending as a PLI or as some other feedback. I think that seems problematic.
I think it would. Yeah, I think it would be problematic if we add that as text in our draft. We expect that the quick implementation will issue or will surface some error to the application, so the application will know there was a stop sending, and then what the application does with it is left to the application. Yeah, I think we don't want to add text that says this specifically.
Yeah, Bernard, I just wanted to add, Meredith and I were talking about this pretty recently, and I think that the more I'm thinking about this, what we meant when we said stop sending as PLI for a new stream actually is pretty close to create an independent next frame. But I think that I agree with your discouragement of guessing what quick feedback, quick error, quick messaging like that actually means.
Right.
In ways that are not defined, and I don't think that avoiding that is going to cause any problems at all. So I think I definitely agree. Thank you.
All right, then we have also talked about closed stream and enough in the past. They are basically the versions of stop sending and reset stream that includes an offset, and the offset specifies up to where a quick stream has to be reliably retransmitted, and after that everything may be unreliable. That sounds useful, but we are not sure how exactly or how relevant it will be in practice, because it allows an application to make earlier parts of the stream reliable, but when the receiver or the sender decides that the later frame is already too late, for example, and we want to cancel it and want to drop this, then why keep the offset to reliably transmit the earlier parts? We currently have a note on this, or a note that references these two drafts in the document, but we would suggest that we don't add more text about what to do with these, and we would only keep them as informative references in the appendix that already lists quick extensions for future use. That might be potentially useful, but since they are not finished documents yet, and we don't really know if it will be very useful, we would not add any more text about this. Yeah, Bernard.
Yeah, so we came to roughly the same conclusion in the Web Transport API. The only place so that we would not add this, so that applications wouldn't have the ability to process, send closed stream or anything like that for the same reasons. The only point of contention was whether it might be useful in a control channel. So in other words, not for media, but for some control reason where you want to make sure that a particular control message arrives. So that was the only place where we thought it might be worth discussing. Because for something like partial delivery, it really doesn't help you.
So and
I
make sure I understood what you just said, Bernard. You're talking about a control channel that's still being transmitted over RTP, right?
Well, in this particular case, we were looking at, for web transport, it was the control channel that sets up the sessions.
Right.
And there it did seem to be useful to have closed stream and know that a particular, like say you were asked for a session to be set up and then you decided to close it, you would be able to say, hey, I want this particular command to get through and be reliably transmitted, but after that I'll do the shutdown. So that it made sense there, but in the case of media, we discussed it and we didn't think it made any sense because, you know, if you're in the middle of sending a frame and decide you don't want it anymore, you're just going to send a reset. And you wouldn't want it to be partially reliable. You just decided you didn't want it to get through, right? So we couldn't think of a reason why closed stream would be useful for media, but the only place where it was debated was in the control.
Okay.
So
yeah.
anyway,
I
basically
think I'm in
what you're
sync.
proposing.
Thank you.
Yeah, I think what you're saying here makes sense. The only place where it might be worth a little bit more thinking might be like, is there some RTCP message you must get there? You know, you want to get there, but otherwise, I think you're right.
For RTCP, I would argue that a receiver should probably not stop sending for RTCP anyway, because it doesn't make sense, I think. And for the sender knows what it wants to get through, right? And if it knows I'm gonna have to open new streams for the following RTCP messages, like if they do stupid things, then like why would he use or need closed stream for this? So I don't think it's very useful for RTCP either. Jonathan.
Yeah, I think given that all of RTP and RTCP is designed, to be for unreliable networks, I think there's no need for something to force something to be reliable, because RTPs and RTCP's own mechanisms will handle that properly. So yeah, I agree with this. And I don't want to have normative dependency on something that's not done yet in Quick if we can avoid it.
Yeah, that's another good reason. So, okay, we will then remove the notes in the main document, keep the list in the, or keep it in the list in the appendix, and yeah, then close that issue. Okay, so this one is one of the things that I mentioned earlier that we merged yesterday, I think. We had some wording on suppressing quick signaling in favor of, RTCP signaling, I think, is in favor of quick signaling. But in the introduction, we said that we don't want to change any of the protocols, so we just need a standard quick protocol implementation, and we also don't want to change any of the RTCP feedback rules. We just want to be able to use quick state information that's there anyway to enhance the statistics that are provided by RTCP. So we changed that wording to don't say that we suppress any feedback and instead enhance statistics, so that we don't require any updates to quick or RTCP feedback rules. And yeah, we merged that yesterday. Then next slide. Yeah, exactly. Then RTCP multi-hop topologies was another issue that we created pull request for that we merged yesterday. This adds a section for considerations for RTCP enhancements in multi-hop topologies, which means, for example, if we have a participant in a session that uses RTP over quick, and then we have a middle box, and on the other side of the middle box, there's a participant that does not use RTP over quick, but some other protocol, then this other participant may need RTCP feedback as usual, and the RTP over quick participant may not send as much RTCP feedback as the other one expects because it can use quick stuff to enhance this. So now we added some considerations for this, for what could be done to solve this problem. So first of all, the previous pull request that I talked before this slide already solves this a little bit, because we still say that we need the basic RTCP receiver reports, for example, so that will still be there anyway. But if the middle box, for example, has some or uses quick acknowledgements instead of relying on negative acknowledgements from RTCP, then one solution would be that the middle box adds them themselves, or another solution would be that we need some signaling that tells the RTP over quick participant, hey, you actually need to do RTCP as usual because there's someone not using RTP over quick, so that the RTP over quick participant can still provide this feedback. And then there are a couple of topologies listed in the earlier sections of the draft, I think. Our C767 has a lot of more topologies. And yeah, there are maybe some topologies that are not covered by this, but yeah, one question that we thought about when we discussed this was, which of these do we actually care about today? And is there any of them that would not work with the solution that we propose here? Yeah, so if you have any feedback for this, then yeah, either now or in the GitHub issue, given that we only have 10 minutes left. And yeah, Jonathan.
I've been, and this may get into more of the signaling issues, which we haven't really talked about yet, but I think all of the RTP mechanisms beyond what the base 3550 does have negotiation mechanisms in SDP, and I think, if there's things you need on the RTP side, then you should negotiate them. And if I didn't negotiate them, then you shouldn't use them, and that sort of gives the flexibility to make sure people have the RTP features they need. So I think which I think probably, hopefully resolves most of these issues.
All right, yeah, that's what the draft now says. And yeah, then next slide is already the last one, I think. It's a list of issues that we are currently focusing on. The first two are finished error codes. We have one pull request for that, which we already merged some time ago, but it's not yet finished. There will be some little additions to that, but it's almost done. And then, yeah, these are the list. Here's the list of issues that we are currently focusing on. There are a couple of more issues in GitHub, but some of them are marked with won't fix or not yet or future document or something like that, because they are things that we can't or don't think we can do really much about yet. For example, multicast, I think we don't need to work on this yet before there's anything that specifies quick multicast or something like that. And then, yeah, the last two issues here on 127 and 128 are very new from Bernard. I think there are a lot of good points in there, which we added to this list, which we are going to focus on next, but we didn't have a chance to look at them in detail yet. Yeah, and I think that's all for today. Any questions? Bernard?
I did have one comment, which is that I'm beginning to see quick implementations incorporate L4S for low latency. So I think there is, and I believe there was some work on Apple in that regard. So I think there does seem to be a coalescence around some of the issues you've raised, but maybe not in the directions you describe in the draft. So just something to look at as the implementation of L4S proceeds.
Yeah, Bernard, this is Spence. I saw a mention of that in the meta issue that you put in fairly recently, and I agree with that, and I appreciate the pointer to Apple as one of the places where that's popping up. That'll be helpful too. Thank you.
Yeah, I don't think we have quite enough information to know about how effective it is, because usually, it's now in iOS 16 and 17, but not quite deployed by the ISPs yet. But anyway,
Yeah.
In terms of implementation progress, it is making substantial strides.
Yeah, and I think that is a very reasonable thing for us to focus on. It may also be worth me just saying, Metis has referred to this a couple of times in the meeting, but he and I are trying to keep the labels on issues up to date and coherent. We have, I think, 3 or 4 issues that have been added since the last time he and I talked that he and I have not added labels to yet, and we'll obviously update labels for things we discussed on this call soon. But I just encourage people to take a quick look at labels anytime that we're getting ready to talk about quick over RTP. Sorry, RTP over quick. Yeah. Anyway, thanks.
Thank you. Okay, Peter, we have a couple of minutes, but luckily you don't seem to have a lot of slides, so take it away.
Yeah, this should be short. Next slide. So since last time, there were 2 pieces of feedback. One was to allow what I was calling the stage 1 or media format specific packetization to output more than one RTP packet, and then to apply the stage 2 or S-frame specific packetization to each one of those packets. So I made that change in GitHub. So it's good. And then the second was that we should issue a call for adoption. So I didn't see the call for adoption happen yet. So I went ahead and renamed the draft in GitHub.
Yes,
but I haven't.
that's on me. I forgot. I apologize. I will do it right after this meeting.
Okay. So I haven't uploaded this to the data tracker yet, the rename, but I did change it in GitHub.
So Peter, maybe you issue it under draft Thatcher and then we do the call for adoption. Does that make sense?
It's current. Oh, do you want the call for adoption to be the one that has the change? The first change? Okay.
Oh, it doesn't. Okay.
I think it's probably cleaner, clearer to just do the. I mean, if it just mostly just to avoid having version thrash in Peter's GitHub, but I mean.
Well, let's go to the next slide.
Okay, sure.
The next steps. So Jonathan's going to issue the call for adoption. And then,
Yes.
assuming it's adopted, I'll submit the renamed draft to the IETF data tracker. And then what?
Then we see if there's still issues, and if not, we do a finger blast call, I think.
Yeah,
Okay.
I would ask, is there other implementation plans for this?
That's a good question.
Yeah, this does seem like something we'd want to have running code for, just to
Right,
make sure we got it right.
Okay, that's good feedback. That's all I got.
Okay. In that case, I think we're done, unless anybody else has any other
Well, I
business.
think we're done for the day. I guess we'll go over the minutes and make sure we've got all the action items and so forth. Any other final words?
Thank you.
And we'll see you all at IETF 118.
Thank you all.
Thank you.